Hello students, now we are going to learn about a switched mode power supply, that is SMPS. The full form of SMPS is switched mode power supply, also known as a switching mode power supply. SMPS is an electronic power supply system that makes use of switching regulator to transfer electrical power effectively. It is PSU, that is power supply unit, and it is usually used in computers to change the voltage to the appropriate range for the computer. An SMPS adjusts output voltage and current between different electrical configurations by switching the basics of typically lossless storage such as capacitors and inductors. Ideal switching concepts determined by transistors controlled outside of their active state that have no resistance when on and carry no current when off. It is the idea why the switches with an idle function will operate with 100% output, that is, all input energy is provided to the load, no power is wasted as dissipated heat. In fact, such idle systems does not exist, which is why a switching power source cannot be 100% proficient, but it is still a vital improvement in effectiveness over a linear regulator. Now, what are the benefits of SMPS? The switch mode power source is small in scale. The SMPS is very lightweight. SMPS power consumption is typically 60 to 70%, which is ideal for use. SMPS is strongly anti-interference. The SMPS production range is large. Now the block diagram of SMPS. First, input rectifier stage. It is used to convert an input to DC. A SMPS with DC input does not require this stage. The rectifier produces unregulated DC, which is then passed through the filter circuit. Now inverter stage. The inverter stage converts DC, whether directly from the input or from the rectifier stage described above, to AC by running it through a power oscillator, whose output transformer is very small with few windings at a frequency of tens or hundreds of kilohertz. Now output transformer. If the output required is to be isolated from input, the inverted AC is used to draw the primary windings of a high frequency transformer. Now output rectifier. If the DC output is required, the AC output from the transformer is rectified. Now regulation. Feedback circuit monitors the output voltage and compares it with the reference voltage. Now, what are the limitations of this SMPS? The complexity of SMPS is very large, the production reflection is high, and its control is weak in the case of SMPS. Use of SMPS can only be a step-down regulator. In SMPS, the voltage output is just 1.